here we are with the last section of the chapter, section 12.7. This section is all about dilations, all right? Okay, so here we are with the last section of the chapter, section 12.7. This section is all about dilations. So our goal is to dilate figures in a coordinate plane, but we're also going to be finding scale factors when we're given a dilation. All right, so let's start with some vocab. What is a dilation? A dilation is enlarging or shrinking an object using a scale factor. Okay. Now, because I use scale factor, I'm going to define that next. So, what is a scale factor? Well, a scale factor is a ratio of your image to your pre-image. Right? And remember, image is what you end with, pre-image is what you start with. So in other words, you're creating a fraction that has the new thing over the old thing. And generally when we're doing this, we talk about side lengths or distances, things like that, not things like area and stuff like that. Okay? Well, also in order to do a dilation, generally we say that there's a center of dilation. For this class and purposes of this lesson, our center of dilation is always going to be the origin. And what that means is the point, what it is it's the point you stretch from. Stretch or shrink from, sorry. Or shrink from. But essentially all you need to know for this class is that our center of dilation is the origin. When you get up into geometry, we look at some dilations where our center is not the origin. But for now, all of our center of dilations will be the origin. All right, so to actually do a dilation, all right, we need to know our scale factor. All right, so like I said, we put the new over the old, and we reduce, and they got 2. That number, or it could be a fraction, but that number is my scale factor. So in this case, my scale factor is 2. Okay, you can describe a dilation with respect to the origin, and again, remember that's always going to be our center for this chapter, using this notation right here. Okay, so circle that, star that. It's important. Where K is the scale factor. Okay, now, what does it mean when the K and the X and the K and the Y are mushed up? Well, remember, that means multiply. So all you're really doing is you're multiplying both the X and the Y by that scale factor, right? So I took A, and I said my scale factor is 2, so times, right, and distribute it to both things, and I got 4, 4. Right, and then you do the same thing for B, so times 2, distribute, and I got 8, 4. Right? So that's really all a dilation is. It's just distribution and multiplying. All right, so let's try one. Example 1. Draw the quadrilateral. Okay, so first we're just plotting points. So A is at -4, 1. B is at 1, 3. Oops, I messed up already. Me and these plotting points, one's 1, 3. Here's B. C is at 1, -1. And then D is at -3, -1. So there's my quadrilateral. Okay. Then find the coordinates of the vertices of the image after dilation having a scale factor of 2. Well, since my scale factor is 2, that means that I need to multiply every x and y coordinate by 2. So xy, in this case, is going to go to 2x, 2y, because that's what my k value is. That's what my scale factor is. So just multiply everything by 2. So a would go to negative 4 times 2, which is negative 8. 1 times 2, which is 2. B prime, 1 times 2 is 2. 3 times 2 is 6. C prime, 1 times 2 is 2. Negative 1 times 2 is negative 2. D prime, negative 3 times 2 is negative 6. Negative 1 times 2 is negative 2. Right, graph my new points. I'm going to do it in a different color so we can make sure we see it. So A prime is at negative 8, 2. This is A prime. B prime is at 2, 6. C prime is at 2, negative 2. D prime is at negative 6, negative 2. Okay, now, unlike everything else this chapter, what we end with is not going to be exactly the same as what we started with, right? It should either be like you zoomed in and it got bigger, or it should be like you zoomed out and it got smaller. Okay? Should be one or the other. And the way you're going to know is you're going to look at this k value. If this k is more than 1, it should be getting bigger. If that k is less than 1, it should be getting smaller. Okay? Alrighty. So let's go ahead and have you try checkpoint 1. The video is going to pause. Go ahead and enter your it's not A, B, C. D prime, E prime, and F prime over on the right hand side, and then hit continue to see how you did and check your graphs. All right, so first it says draw the original. So negative 3, 2, that's D. 1, 2 is E, and 1, negative 1 is F. Connect my dots, there's that triangle. Okay, so now my scale factor that it wants me to use is 3. So I'm just multiplying everything by 3. So D prime would go to negative 9, 6. E prime would go to 3, 6. F prime would go to 3, negative 3. Plot those new points. So D prime, negative 6, or negative 9, comma 6. E prime, 3, comma 6. Oh man. F prime, 3, negative 3. Connect the dots. Right? And we should have known that it was going to get bigger because the scale factor was 3, which is more than 1. So it does look like the same kind of triangle, just a bigger version. All right, let's look at example 2. Example 2 says, draw a triangle PQR with those vertices. All right, so I'm going to go ahead and draw that triangle. So P is at negative 8, 4. Q is at negative 6, 6. And R is at negative 4, negative 2. So this is a really stretched out skinny triangle. Alrighty. Then it says find the coordinates of the vertices of the image after dilation having a scale factor of 1/2. So now my scale factor is 1/2 or 0.5. So I'm going to multiply everything by 0.5. So it's going to go to 0.5x, 0.5y. All right, so 1/2 times negative 8 would be negative 4. 1/2 times 4 is 2. 1/2 of negative 6 is negative 3. 1/2 of 6 is 3. 1/2 of negative 4 is negative 2. 1/2 of negative 2 is negative 1. Plotting my new points, P prime is going to be at negative 4, 2. Q prime is at negative 3, 3. R prime is at negative 2, negative 1. Connect my new dots. And as you can see, it's the same kind of triangle, just smaller. Because like I explained earlier, if your scale factor is less than 1, meaning it's like a fraction or a decimal, your picture will get smaller. not bigger. All right, let's look at example 3. An artist uses a computer program to enlarge a design as shown. What is the scale factor of the dilation? Okay, so in order to know the scale factor of the dilation, you have to look at matching coordinates, okay, or distances. So in this case, the width of the original design, right, is 3, or is 2, right? 3 minus 1, the x coordinates, 1. So 3 minus 1, which is 2 units, okay? The width of the image, so look at your x's, would be 9 minus 3, which is 6. So the scale factor, remember, we put new over old. So the new is 6, the old is 2, and 6 over 2 reduces to 3. These units cancel, so your scale factor should never have units on it, right? It's just a number, it's just a ratio. Alrighty? Hopefully that makes sense. If not, make sure, if you ever have questions, make sure you're asking Miss B or tracking down Mrs. Schmidt, or I will be back tomorrow. Alright? So, with that, let's have you try checkpoint 2. So now it gives you 2 ordered pairs, and it wants you to find the scale factor. Okay? So remember, these are your originals, these are your news, so find your scale factor. Alright, so go ahead and enter, the video's going to pause, enter your answer over on the right-hand side, and then hit continue to see how you did. Also, just a heads up, there is more than one way to do this, so if you did this a different way, but you got the same answers I'm going to get, there's very good likelihood that you still did it right. Okay, so with that, what I am going to do is I'm going to look at C, and I'm going to look at D, or C and C prime, sorry, C and C prime. And you can just pick one ordered pair. That's the easiest way to do this, in my opinion. And I'm going to say, okay, how do I get from 6 to 2? Well, I would divide by 3. Right? How would I get from -3 to -9? Oh shoot, I did this backwards again. I'll get there eventually. How do I get from -9 to -3, right? Yeah, that's right. Original to the new. Well, I would divide by 3, right? And these should be the same. These two things here, they should be the same. But we don't like to think of scale factors in terms of division. We like to think of them in terms of dividing, or of multiplying. So instead of dividing by 3, I'm like, what can I multiply by that's the same as dividing by 3? Well, the answer is 1/3. Right? If you don't believe me, okay, let's check my answer using the D's. All right, so if I look at the D's, I take -3 times 1/3, I would get -1. Does -3 go to -1? Absolutely. Okay, let's check the Y's. 1 times 1/3, well, 1 times anything is just itself, so 1/3. And this Y goes to 1/3, so that's perfect. Right? So you could pick C's to compare, you could put D's to compare, but you have to compare the same point to its image. Alrighty. Hopefully that makes sense. If not, again, just take your notes over, ask Ms. B to maybe help you figure it out. Otherwise, I will be back tomorrow, or you could ask Mrs. Schmidt probably during resource time. All right, so a little summary here of the whole chapter now. Okay, so for translations, in a translation, each point of a figure is moved the same distance. Right? Because a translation, reminder, is a slide. Right? So each point is moved the same distance in the same direction. So xy goes to x plus or minus a number, and then y plus or minus a number. And remember, the plus and minus depends on which way you're going, right? Plus means up and right. Minus would mean down and left. Okay? Reflections then. So we learned about translations first, then reflections. In a reflection, a figure is flipped over a line. So we had those two rules. We had reflection, the x-axis. We had xy goes to x negative y. And then for the y-axis, our x changed. So we had xy goes to negative x, y. Oh, my comma missed. There we go. Okay, so those were our two rules for reflections. Then we moved on and we did rotations. So in a rotation, a figure is turned about the origin through a given angle and direction. And remember, our two directions were clockwise and counterclockwise. All right, for 90, we had three rules here. For 90 degrees clockwise rotation, which is what's shown in the picture, we had xy goes to y negative x. For 90 degrees counterclockwise rotation, we had xy goes to negative yx. And then for 180 degree rotation,